So what we're going to do now is we're going to go into 3.4. And in 3.4, we're going to be proving that lines are parallel. All right? And this is where we're going to start here. So the very first thing, and actually in 3.3, we were given, right, that if we had parallel lines, then we have these angle relationships that exist, that alternate exterior, alternate interior, and corresponding are all congruent angles, and consecutive interior is supplementary, right?
Yeah.
3.4 is basically the full converse of everything that you learned in 3.3. So take a look at page 150. They're basically saying there that if you come across a couple of lines where the corresponding angles are congruent, you can go ahead and assume those lines are parallel. Okay, so you remember converse is if P then Q. I mean, the conditional is if P then Q. The converse is if Q then P, right? So they're turning this around and saying, instead of saying, if I've got parallel lines, the corresponding angles are congruent, they're saying, if my corresponding angles are congruent, then my lines are parallel. Okay, and that's a postulate, just like the other one was a postulate, corresponding angles postulate. The converse is the postulate as well. And you have the same deal, alternate interior, consecutive interior, and alternate exterior. So basically they're saying, as far as the alternate interior and exterior goes, if those angles are congruent, you got parallel lines. The theorem 3.9, the consecutive interior angle. So we're on page 150, by the way. If it says if the consecutive angles are supplementary, then you know you're looking at a pair of parallel lines. Okay, that's basically it. All right, so let's take a look at example 1. We're going to actually do this proof. Okay, and I want you to not look in the book because I want you to give me the reasons. Okay, and how are you doing with your reasons sheet?
I'm doing all right.
Do you have it caught up?
Yeah, like I think I might have a few to do from the last lesson, but
okay.
I have a bunch right now.
All right, so good. So say what? You don't have a printer?
No, I have a bunch right now, but I have to do some from the last lesson.
Oh, okay. Okay, gotcha. All right. Yeah. So, and you might have to print, several of the page too, because you're going to go over.
Yeah, I've already had to do that once.
Okay, all right, good. All right, so get that caught up, because I think the act of writing those in is when the theorems and the proofs and stuff like that kind of come together, because then you're like, oh yeah, I remember what I can say here.
Okay.
All right, so here you're given that angle 1 and 2 are congruent. Okay, and you're going to prove, and we're proving the alternate interior angles converse. Okay, so angle 1 and 2 are alternate interior angles, right?
Okay, yeah.
And we're saying, okay, these are alternate interior angles. They happen to be congruent. We're going to prove that line M and N are parallel. All right, so let's start here at the beginning. First statement and reason. I'm going to be told that, angle 1 is congruent to angle 2. Okay, what's my reason?
It's given.
Given. All right, now I'm going to say angle 2 is congruent to angle 3. Why can I say that?
Alternate interior angles postulate?
No. And well, first of all, alternate interior angles is not a postulate, it's a theorem.
Okay.
And I'm trying to prove the alternate interior angles converse. Okay, now, so what relationship do 3 and 2 have to each other? They're not alternate interior angles. One and 2 are.
They're vertical angles.
Mm-hmm.
Okay.
So what's my reason?
Vertical angles postulate.
Vertical angles theorem. Theorems are the ones that get proven. The postulates are the ones that are universal truths. So that was proven. Okay, so now I'm going to say, well, if angle 1 is congruent to angle 2 and angle 2 is congruent to angle 3, I'm going to say angle 1 is congruent to angle 3. What's my reason?
The transitive property.
Transitive, yes. Oops, and why did everything go away all of a sudden? Okay, transitive. Why? Did it blank out for you too?
No, it's
weird. Okay, because it blanked out for me. It blanked out some of what I wrote. I don't know why. Okay, so then I'm going to say, well, line M is parallel to line N. How can I say that? Think about the one postulate we do have. What's the relationship between angle 1 and 3?
They're vertical angles. Wait, no. They're corresponding.
They're what?
They're corresponding.
They're corresponding. And we have a postulate here we can use, right? Corresponding what?
On the angles postulate. Or, yeah.
Converse postulate. Right?
Okay, yeah.
Because remember, what we're trying to prove now is that the lines are parallel. We're saying that the angles, the corresponding angles are congruent, so therefore the lines are parallel. Okay? Does that make sense?
Yeah. Mm-hmm.
Okay. All right. All right, let's do example 2. All right, and this one we're going to prove the consecutive interior angles converse. Now, what's the relationship between consecutive interior angles?
They're congruent?
No, consecutive interior angles are not congruent.
Oh, they're a linear pair.
They're not a linear pair either, because they're not adjacent.
They're supplementary.
They're supplementary, yes. Yes, yes, yes. Okay, there's a difference between all that, right?
Yeah.
Yes, linear pairs are supplementary, but that doesn't make supplementary angles a linear pair. Does that make sense?
Yeah.
Okay. All right, 6, 5, 4. Okay, this is line G. This is line H. Okay, you're given that angle 4 and angle 5 are supplementary. So we're saying if they're supplementary, then they're parallel. Okay, the lines are parallel. And we're going to prove that the lines G is parallel to line H. Okay? All right. Statements, reasons. Okay, 1, given. Okay, we got that. Okay, angle 1 and 4 is supplementary. Got that. Okay, so what do I know about angle, I'm going to say angle 5 and angle 6 are supplementary. Why do I know that?
Because they're a linear pair?
Yes. So linear pair postulate says that. Right?
Yeah.
Okay. Now, and then my given was that angle 4 and angle 5, right, are supplementary.
Mm-hmm.
Okay, that was my given. And now I just said that 5 and 6 are supplementary. So now I'm going to say that angle 4 is congruent to angle 6. Why can I say that? Because think about it. Angle 4 and 5 are supplementary, and 5 and 6 are supplementary. So what do I know about 4 and 6?
That they're interior, yeah, of course, alternate interior angles.
Well, they're not. They're consecutive. They're consecutive interior angles. 4 and 5 are.
Yeah.
Because they're on the same side. So they're okay. But okay. Think about this for a second. We're saying that 5 and 6 are supplementary, and we're saying that 4 and 5 are supplementary. Okay. Remember the congruent supplements theorem. Okay, further back. Let's look back at page. Let's see. Look on page 111.
Okay.
Look at theorem 2.5. Congruent supplements theorem. What does that say?
If two angles.
2.4. I'm sorry, 2.4.
If two angles are supplementary to the same angle or to congruent angles, then they are congruent.
Yeah. So look at that. Angle 1 and angle 2 are supplementary, right?
Yep.
3 and 2 are supplementary. So that means that 1 and 3 have to be congruent, right? They're the same angle.
Okay.
Right. So think about it. If angle 1 is 30, okay, and angle 2 is 150, all right?
Mm-hmm.
They're supplementary, right?
Yes.
Then if we say that angle 2 and 3 are supplementary, then angle 3 has to be what? 30 degrees, right? So that means that angle 1 and 3 are congruent. So this is saying here, this is saying, okay, I was told that 4 and 5 are congruent. I'm not congruent. 4 and 5 are supplementary, and I know that 5 and 6 are supplementary. So what do I know about 6 and 4 then? They got to be congruent, right?
Yeah.
Because of the congruent supplements theorem.
Okay.
So congruent supplements, whatever theorem. Okay. All right. So now I have just proven, okay, and now I know that 6 and 4 are congruent because in example 1, what did we prove? We proved
The alternate interior angles converse.
yes. So now we proved that if alternate interior angles are congruent, that the lines are parallel. So 4 and 6 are alternate interior angles, right?
Yep.
So, and we proved that if in example 1, we proved that if you have congruent alternate interior angles, that the lines are parallel. So we can simply say, well, G is parallel to H because of the alternate interior angles converse that we just proved. All right, let's look at example 3. Okay, I'm being told that I have a line J and a line K that are parallel. Oh, it says they're not parallel, necessarily parallel. I'm being told that I need to find the value of x that would make these lines parallel.
Okay.
Okay. Missing your words. Your choices are these: angles and consecutive interior angles. Okay. All right. So what's the relationship?
They're consecutive interior angles.
Yes. Good. And what's the relationship? And what do consecutive interior angles have to be in order for the lines to be parallel?
They got to equal 180.
All right. So how am I going to do that using my algebra? I have to say x, right, plus
4x
equals
180.
Yeah. So what's the next step?
Simplify like terms.
Mm-hmm. What am I going to get?
5x equals 180.
5x equals 180. Good. And now what? Divide
You
by 5.
divide 5 from each
And so
side.
x is going to equal 36, right? So, yeah. So x has to be 36. So this is going to be 36 degrees, and whatever, this is going to be 4 times 36. And that'll add up to 180 when we do that. Okay. All right. Now, let's take a look at example 4, which is their real life example, I guess. They're saying I've got 2 boats. Okay. Here, this is a boat. That's a boat. Here's another boat. Okay, it's a good thing I don't need to make my life living as an artist. Okay, and it's going like this, and this is going like this. Okay, and I've got a wind pushing everything at kind of a 45-degree angle. Okay, and that's 45, and that's 45. And the question is, as long as the wind stays constant, do I have to? Will the boats ever cross paths?
No.
Okay, and what's your reasoning?
So both angles are corresponding angles, right?
Yes. So they're going those lines therefore are parallel, right?
Yeah.
So those lines are going to be parallel, and so that therefore the paths will never cross. Okay, because by definition parallel lines. All right, good. That was easy. All right, now let's look at example 5, and that's the last thing in this section. All right, let me do all my little labeling here. This is E. This is A, B, H, C, D, G. Okay. And they're telling us that this is 62 degrees, and that this is 58 degrees, and this is 59 degrees, and this is 61 degrees. Okay, now the question is ray EB parallel to HD? So EB is this one, and HD is that one. Are they parallel?
No,
Okay, and why not?
because like they're corresponding angles, but they're not congruent.
That's
So they
right. So they're not. Okay, then the question is EA, is this parallel to ray HC?
No,
Why not?
because again, like 62.
Well, what is this? What's this angle? What's that angle?
Do we know?
Well, you know this is 58, you know that's 62, then what's this got to be?
Oh,
So 62 plus 58 is 120, right?
okay.
So what
then
is this? What is this?
160.
Just
Or
60. Yeah. All right. And then this is a 59 here. Okay, so 69 and 51, what does that add up to?
It's going to be 120.
And so this is 60. So are
Okay.
these parallel?
Yes.
Yeah, because their corresponding angles are too. So when you were looking at these, those aren't the corresponding angles to this ray, right? These rays right here. You had to look here, or you could have looked at these to the sum of these, because this sums up to 120, and this sums up to 120. Okay, to look at these rays. Okay, you could look at this angle or this angle, this angle or this angle, and those are congruent, 60 and 120. Okay. Does that make sense? The difference of what we're talking about there? Okay. All right, good. All right, here. I'm going to stop this video and I'll start another one.